Hello students, this is video 1.12. The objectives today are I can reflect a figure about a point and I can determine if a figure has line symmetry. Okay, so let's go flippers. The first thing you need to remember about reflections is that reflections, flips are RMTs, and we talked about that in class already. So reflections are everywhere, in mirrors, glasses, and here in this beautiful lake that you see right here. So line symmetry is when the image contains a line of symmetry within itself. So if you look at this magical bean here, and you imagine if it has any lines of symmetry. So I'm going to use a black line. And if I go vertically like this, well, if I were to fold this over, it would not fit perfectly on top of itself. So that's not line symmetry. But if I go horizontally, you can see that this definitely has line symmetry. It would fold right on top of itself. Okay, so two reflections that are really important are going to be one reflection over the x-axis and then the other over the y-axis. So if we look at our pre-image figure here, here is our pre-image. So ABC is our pre-image. And if we look at this, we can see that this figure, this triangle, has been reflected or flipped over the x-axis. Here's the x-axis right here. So now we can see C and C prime, A and A prime, and B and B prime. And what you should notice is that when that happened, all of the x coordinates stayed the same, but the y coordinates switched. So the ones that were positive became negative. And if this was the other way around, and we were down in this section, had this been the pre-image, then they would have actually flipped or rotated up toward this image. And then the positive ones or negative ones would have become positive. So let's think about what would happen if we had a reflection now over the y-axis. So again, if we start with beginning with DEF, this triangle here, and now reflecting it about the y-axis, we can see that it reflects right over so that D correlates to D prime, F to F prime, and E to E prime. And again, if we look at the mapping, because that's what this actually is. This is a mapping that tells us what's actually happening. XY goes to mean negative XY. And we can see that very clearly because D, which is negative 10, 0, maps to 10, 0. So let's look at the examples for question number 1. The first example says, point A is located at 4, negative 7, and the point is reflected in the x-axis. The image is located where? Here's my point 4, 7, and they're saying that this is reflected in the x-axis here. So I know that it's going to shift and move this way. There's my new point, and my new point is going to be now at negative 4, negative 7. So that means my answer is 2. Number 2 says, if the point 2, negative 5 is reflected in the line y equals x, then the image is, here's my original point, 2, negative 5. What's really cool about this reflection is that this is the line y equals x. And we're doing a reflection in this line. So what happens with the point is that these points, 2, negative 5, they actually flip. So the coordinates of the new image would be at negative 5, 2. So that's going to be left negative 5 and then up 2. And that would mean our point is here. Answer number 1. But not least, our final question says triangle ABC has coordinates A, 2, 0, B, 1, 7, and C, 5, 1. And then it asks us to use the axis, graph, label, and state the coordinates of the new reflection in the y-axis. So here are our 3 new points, B prime, A prime, and C prime. B prime is at negative 1, 7, A prime is at negative 2, 0, C prime is at negative 5, 1. And we've clearly graphed it as well. And last but not least, we have our secret hot question, which says, when the point 2, negative 5 is reflected in the x-axis, what are the coordinates of the image? Please make sure when you answer this question, you can show how you got it done.